So let's talk in a little bit more detail about writing methods. So before you ever think about how to implement or write the code that goes inside your method, you need to think about defining the method header, the method declaration. That really sets up how the method's going to work because it defines the inputs, the outputs, and the visibility. So you need to think about all these things. You need to think about what kind of input do I need into this method? What do I need to take in to accomplish this method? What am I going to send out? What's the output of my method going to be? What am I going to call my method? And I want to think about following conventions when I do that. And then what's my visibility? So who's going to need to use this method? So let's look at a couple examples. Here are 4 methods. We're not going to write these methods. We're just going to think about how we declare them. So for example, let's say we wanted to write a method to print out common mathematical formulas. What would the input of this method be? Do we need any outside information to accomplish this task? I don't think we do, right? We are going to print out, let's say, area and perimeter and a bunch of different formulas. If we wanted to do that, we don't need any outside information. We can just write what we need right inside the method. So our parameter list will probably be empty. What's our output going to be in terms of a return value? Now remember, output doesn't mean a print line statement. That all happens inside the method. Output means a returned value. Are we going to send back an output value? Well, we're probably not. So this method can probably be void because it's probably not going to send anything back to the class that called it. What might the name of this method be? Well, it might be something like display formulas or print mathematical formulas using lower camel case. And then this, along with the other methods in this example, are probably all going to be public because without knowing more about them, we're probably writing them so that an outside class can use them. We'd have to know more about the problem, though, to know that. This next example, write a method to calculate the area of a triangle with integer base and height. So what are the inputs? The inputs are going to be the base and the height. You need to tell me what those values are so that I can accomplish the task. So I would have 2 parameters, int base and int height. And then what's the output? The output's going to be the area. Now that could have a decimal portion, so the return type of my method is probably going to be a double, or it could also be a float, even though my parameters are int. And then the name of this method might be calculate area or find area or calculate area of triangle, something like that. What about a method to calculate the distance between 2 points? Well, what are the inputs? Well, I need to know where the points are. So I could do that by using 4 numbers, right? Int x1, int y1, int x2, int y2. Or I could look up and find that Java actually provides a class called point that does just what I think it would do. It keeps track of the location of a point, and I could take in 2 parameters of the type point. That would be another option. The distance is going to it could potentially have a decimal, so my return type is going to be either double or float. And then the name of my method might be calculate distance or find distance, something like that. And then finally, what if we were writing a method to determine whether a triangle is a right triangle? That means it would satisfy the Pythagorean theorem, a squared plus b squared equals c squared. Well, I would need information about the lengths of the sides of the triangle, so I'd probably take in 3 parameters of either int or double, side 1, side 2, side 3. And then what am I returning? Well, I'm returning either true or false, right? It either is or it isn't a right triangle. So my return type is probably going to be a Boolean. And my method might be called isRightTriangle, for example. Oftentimes when we have a Boolean return type, our method names start with is, because really a Boolean method is kind of asking a yes or no question. Is it or isn't it? So you might have a little bit different answers for this, but these are essentially what we just said, public void print formulas with no parameters. Oops, public double calculate area with 2 integer parameters. Public double calculate distance with 4 integer coordinates, or public double calculate distance with 2 point parameters. And then public Boolean is right triangle with 3 side length parameters. So these are all the things you need to first think about before you ever think about how you're going to write your method. You need to think about the inputs, the outputs, what you should call your method, and what the visibility should be. So let's go ahead and add a role method to our die class. Now, for right now, we're going to make a pretty boring, predictable die, meaning that if it's just going to increment what number is showing. So if the die is currently showing a 2 and I roll it, it's going to show a 3. If it's showing a 3 and I roll it, it's going to show a 4. Eventually, we're going to make this die a little bit better and, have an actual rolling functionality. But for now, we're just going to make it pretty predictable, and we'll work on improving it later on. So let's go back to our die class here, and we want to write a roll method. So we need to think about inputs, outputs, visibility, and the name. So let's first think about the input. Now, this roll method is going to go inside of my die class because it's a behavior of a die object, right? So far, I can create my objects, I can access and change the value, the number that's showing, and I can get a text representation. And now I want to add a method to allow me to roll the die. So that method's going to go inside this class. So what inputs do I need for that method? I don't need any inputs, right? I don't need any outside information in order to roll the die. I have all the information I need right here, which is the face value. I don't need you to tell me anything else in order to accomplish the task. So I'm not going to need any inputs. So my parameter list is going to be empty. It's really important that you understand why we don't need to take in this as a parameter, right? Because it's already part of the class. Every die object always knows what its face value is. So I never need to pass it as a parameter. It always knows what it is. It's part of what defines it. Okay. Now, what is my output going to be? Well, there's a couple different options, right? My output could be, I could send you back the new number that's showing, so meaning that my return type would be an int. Or I could also make this method void, meaning I'm going to accomplish the task and then not return any value, right? Saying that, well, really all the roll method is supposed to do is change what number is showing, but it's the job of this method to tell you what that value is. So either one of those are valid approaches, and two people writing their solutions might take different approaches, and both of them would be completely correct. So let's go ahead and start writing. Let's think about our last piece, visibility. This is going to be a public method because the whole point is I want to allow other classes the ability to roll my die object. So it's going to be public. For now, I'm going to write this as a void method. Again, I can see the argument for making it an int, return an int, but I'm going to write mine as void. I'm going to call it roll. That's pretty descriptive, even though it's short, still pretty descriptive of what it does. And then remember, I'm not going to take in any parameters. So that's going to be my method header, public void roll. So remember what I said, my initial implementation of this method is just going to be to increment by 1 the value showing on the die. So I'm just going to take my face value and I'm going to increment it. Remember that this is the same as saying face value gets face value plus 1. So when I first set up my die object, I initialized face value to be 1. And now anytime the client rolls the die, if it's a 1, it's going to be a 2. If it's a 2, it's going to change to a 3. If it's a 3, it's going to change to a 4, etc. So this is going to work great until I have a 6 showing. When I have a 6 showing and I roll my die, face value is going to be incremented to 7. But that doesn't make sense, right? Because this is supposed to be a 6-sided die. So what I need to do is I actually need to add a conditional in here. We haven't talked about conditionals yet, so the syntax of this might not make sense. That's okay. Just go with me for a bit, and we will eventually learn exactly how to do this. I'm going to make basically a very simple conditional that says if my face value is greater than 6, what I want to do is kind of reset that die. I want to reset it back to be 1, right? Because if it's showing a 6 and I roll it, I want it to go back to a 1. Well, if it's showing a 7, for example, if right here I'm incrementing 6 to be 7, and I want to reset that back to 6, back to 1, is there an operator I can use to do that? In fact, there is. I can use my handy modulus operator. I can say face value gets face value modulus 6. Because if face value is 7, 7 mod 6 is going to be 1, right? Because remember, if we have 7 gold bars and 6 people, how many gold bars are going to be left over after evenly dividing up all the gold bars? It's going to be 1. So this is a great way, a great instance of which I can use my modulus operator, but I only need to do that if I've incremented face value beyond where it needs to be. So if face value is 1, it's going to increment to 2, and then 2 is not greater than 6, so this whole if statement will be skipped. If 2, it's going to increment to 3. This will be skipped. If 3 to 4, and this will be skipped. 4 will increment to 5, and this will be skipped. 5 will increment to 6, and this will be skipped. 6 will increment to 7, and then this will execute and reset face value back down to 1. So if the syntax of this if statement isn't clear to you, don't worry about that. We're going to cover that in detail. But for now, I'm just using it so that you can have a functioning die. Now, you'll notice I put the number 6 in here twice. And if you remember, I said anytime you find yourself typing hard-coded values like numbers or text, think about whether you should use a constant instead. Well, should we use a constant? Does it make sense to use a constant here? Well, is the number of sides in our die ever going to change? No, it shouldn't, right? If we have a 6-sided die, it should always have 6 sides. And might it make more sense if this said number of sides? It might. So let's define a constant at the beginning of our class. Remember, it's okay to make constants public because they're constants. They can't be changed, so it doesn't violate encapsulation to make them public. And this is going to be an integer, and I'm going to say number of sides, and I'm going to set it to be 6. So now, instead of putting a 6 in my code down here, I'm going to have number of sides. The code's going to work the same way, only the benefit of this is, first of all, it's clear when someone reads this, oh, if my face value is greater than the number of sides, hey, well, obviously that doesn't make sense. So I need to take the modulus to get that back within a normal range. The other benefit is, if let's say all of a sudden someone decided, actually, I want this to be an 8-sided die instead of a 6-sided die. Well, hey, all I have to do is go in here and change this to an 8 in one place. Rather than finding all the places throughout my code that there's a 6, I can just change it in one place, make it an 8, and hey, guess what? This code will work exactly the same. I don't need to change this roll method at all. Now, face value will increment 1, 2, 3, 4, 5, 6, 7, 8. Then when they roll again, it'll increment to 9. Oh, hey, 9 is greater than 8, and it'll come in here and set it back to 1. So here's a real clear example of why it's great to use constants, because if we change our minds later on, we can again change that value in one place, and I don't have to change any of the rest of my code. The rest of my code still works great. Okay, so now we've got our die class pretty much completed. It's a pretty boring and predictable die, and we're going to fix that later on, but it works, right? It's got a way to set up the object, to access the instance data variable, to get a text representation, and it even has a class-specific method allowing us to roll the die.